So this is a new preprint in ResearchGate that we have published recently on the possibility of using AI to control hygromorph machine. So basically one of the big hurdles to be able to use a type of structures in industrial application in the insufficient control that we have so far. So we were inspired by physical neural network, which is our system which are able to physically approximate functions with different parameters. It's used a lot in optics. And we are also inspired by motor units, which are action neurons that are able to contract muscle inside the human body. And we adapted it to the specific material actuators that we are used to working with. What the idea was to relate the input, so the input light that we have towards a self-actuating window, to the output light that we want to achieve in an industrial application to be able to control the desired light that enters inside the building, for instance. So in order to do this, we created a specific combination of actuating materials with electrically conductive composites in order to be able to assign a voltage into a conductive material, which is able to control the amount of deformation of the system. On the right side, you can see that QSDF is a type of system that we've highlighted with 4 different self-actuating windows on top of each other. And by assigning voltage inside each conductive material, you are able to control locally the amount of deformation of each individual actuators. So after positioning all the different windows on top of each other, we are able to create a model with the temperature, continuous light input, and relative humidity as input, and the light desired inside the system as output. You had voltages relating both of them. And then a surrogate model with artificial neural network was created. So this model used as input the input light, the relative humidity, the temperature, and all the voltages inside for each individual self-actuating windows, and as output the light desired by the applications. And then we were able, with a genetic algorithm, to optimize and obtain the ideal voltages in order to obtain the targeted light output from the input of temperature, relative humidity, and light. And therefore, by assigning these voltages to the system, we were able to achieve required light. In order to train the model, we created a database of more than 300 points, which relate each individual voltage, the input, to the output of the system. And then we highlighted different configurations in different scenarios in which the system is able to prove that it is able to obtain the targeted light, making more control and more industrial application for actuating structures. We were also able that the system to show that the system as a whole is able to learn its behavior on its own, as by letting him behave inside in his own environment, is able to gain more data, and by getting more data, he gains more information that he's able to use in order to refine his prediction and therefore refine the potential of precision for the output light, therefore refining industrial application possibilities.